Hello everyone. This is the last lesson for chapter 8, section 8.5. In this lesson, I briefly show you how to estimate the appropriate sample size that you would need if you are trying to create a confidence interval for the mean or for the proportion. First of all, so to figure out how large a sample you would collect, so there are two scenarios like I mentioned a few seconds ago. One scenario is when you are trying to estimate how large your sample should be to estimate the population mean. So for example, suppose you wanted to estimate the average age of say students with a 95% level of confidence, and you want the difference between the actual population average and the sample average that you're going to get to be like half a year, okay? Right? The difference between the actual population parameter and the sample statistic you're using, you want that to be half a year, and you know sigma, population standard deviation, okay? Your n is this formula as shown here, right? And that n, that formula, you have that in your formula booklet, right? This is your n right there, okay? Z sub alpha over 2 times sigma over E all squared, where E is the error. That's the difference between the population parameter and the sample statistic. That's what I was saying a few seconds ago. So this E here is X bar minus mu. Okay, so what that would be, right? And many times, sometimes you are given the range in the question. You can estimate and say that your standard deviation for the population is approximately a quarter of the range, okay, if that's what you are provided, okay? Or if you wanted to figure out or estimate the percentage of all American voters that will vote Republican in this fall's elections with a 99% level of confidence, and you want a 1% deviation from the actual population proportion, okay? If you know P, right, the population, so maybe in the last election, right, the population proportion of support for the Republicans, you have access to that information. That's what your P is, right? So that's a previous reliable population proportion that was used before, right? So using that information, you can substitute in your N formula here to figure out the sample size you're supposed to get. Sometimes you don't have enough information to know the population proportion from a previous as a previous estimate, okay? So if you didn't know anything about P before, you will just assume that P is 0.5, okay, in which case Q will be 0.5 as well. Okay, so that's how we're going to proceed with these. So for instance, we want to determine the sample size necessary to estimate the population mean for the following information. So population standard deviation is given as 36, the error range is given as 5 at 95% level of confidence. So our formula is as shown, N equals Z sub alpha over 2 times sigma divided by E, everything all squared. We know that sigma is 36, we know that E is 5, and we know Z sub alpha over 2. Now, if your level of confidence is 95%, right, that means that the area in the tails is 5%, like we discussed previously. That's how to find your Z, you know. So if it's 5% in the tails, then half of that will be 2.5%. Okay, so you're looking for 2.5% in one tail. So what is the area? The area you're looking for your Z table will be 0.4750, okay, which will give you a Z score of 1.96. Okay, I hope that's clear. We already looked at that previously. That's why I'm not showing you the tables here in this example. So once you have all this information, all you have to do now is substitute in the formula, and then you will just compute in your calculator. You get 1.99.14. So whenever you are calculating the sample size, you always round up to the next whole number, up all the time, not to the nearest whole number. You always round up to the next whole. So this one, you will have a sample size of 200 to do what you want. Okay? Let's look at another example, right? You have values that range from 50 to 108. The error is to be within 3, and the confidence level is 88%. So this one, again, you are trying to determine the sample size that's necessary to do what you want. To do that, again, our N is as shown, right? The formula for N is Z sub alpha over 2 times sigma divided by E, everything all squared. We know that sigma, which is the population standard deviation, we can estimate 1/4 times range. The question told us what the range is, right? we are told that the range is, I'm just going to go back to the previous page. The range is from 50 to 108 is the range, okay? So using that information, 1/4 times 108 minus 50, you will get 14.5, okay? That will give you an estimate, okay, a rough estimate for sigma, which is the population standard deviation. Then we know an error, we know the error range is 3 according to the question, and so we can find our Z. Okay, we are trying to do I think this one is an 88% confidence level. So that means that 12% is the error, and you want an area of 6% in the tails. Okay, so in your table of values, you'll be looking for an area of 0.4400, and that Z score is 1.555. If you substitute that in your formula, all that information there, you can compute what your N will be. It will be 56.49, which you can approximate to 57. Let's see another example. A bank officer wants to determine the amount of the average total monthly deposits per customer at the bank. He believes an estimate of this average amount using a confidence interval is sufficient. How large a sample should he take to be within $200 of the actual average with 99% confidence level? He assumes the standard deviation of total monthly deposits for all customers is about $1,000. So this guy wants to estimate, he wants to create a confidence interval to estimate total deposits, okay, at a bank. That's what he wants to do. And he's wondering what size of sample he should use. So that's like what we've been talking about, right? So he's trying to estimate the population mean. He needs to know what the sample size should be. According to our question, we know that the population standard deviation is $1,000, and he wants to estimate with an error range of $200, and he's trying to create a 95% confidence interval. Oh, sorry, not 95, 99% confidence interval. So that means that the error in the range is 1%, and half of that is 0.5%. So that's Z sub 0.005. If you use your Z tables properly, you will find that the Z score, or the critical value, is 2.575, which if you substitute all this in your formula as shown, your result will be 165.77, which is approximately 166 customers is what he has to take. Let's see one more example before you try one. What proportion of assistants of Report on Business magazine top 1,000 companies has a scanner at his or her workstation? You want to answer this question by conducting a random survey. How large a sample should you take if you want to be 95% confident of the results, and you want the error of the confidence interval to be no more than 0.05? So this one is a proportion one. You want to figure out how large your sample should be if you're trying to create a confidence interval to estimate the population proportion. According to what we discussed a few minutes ago, the sample size is given by n equals z sub alpha over 2 squared times p times q divided by e squared, which is the error range. Okay, in this question, or in this example, we can figure out z sub alpha over 2 because we're trying to create a 95% okay, confidence. So that means the error, the z value will be 1.96. That's our critical value. In this example, we don't know anything about the population. We don't have any previous data giving us what the population proportion is. So because of that, we are going to assume that P is 0.5. If we had some information previously that told us something about the population proportion previously, we would use it, okay? But because we don't know, we are assuming it's 0.5 for both of them. So once we do that, we substitute in our formula, given that the error range is only 0.05, it's a proportion. If we substitute, we will obtain that n is 384.16, which will be approximately 385. So now you try one example by yourself, and like we've done before, what you want to do is you want to pause this video now while you try this example, and when you have finished, you can continue to the video to see what I have done. Okay, so please pause the video now. All right, so what did you do? First of all, let's read the question. How large a sample is needed to estimate the average number of sick days taken per year within 2 days of the actual average if the population standard deviation is 6 days. Use a 92% confidence level. So we're trying to estimate the population mean for this one, right? That's what we're trying to estimate. And we know what the population standard deviation is, and we know the error range, and we know the confidence level. Our formula for that is n equals z sub alpha over 2 times sigma all over e, all squared. According to our question, we know that the population standard deviation is 6 days, and the error range is 2 days. Our critical value z sub alpha over 2, we are trying to create a 92% confidence level. That means that the area in one tail will be 4%. So we are looking for 0.4600, or what is closest to it. If you look at your table of values properly, you will see that that number is 1.75. So we'll just substitute all that information now in our formula for n, and we can compute. You will see that your answer there should be 28, should be the sample size. Okay, I hope you understand this. I will put up stuff on YD Plus for you to try, okay, for practice.